Does Greek life dominate your campus, or are fewer students joining than expected? Greek life is often seen as a huge part of the college experience, but how many students are actually joining? Let's say your school believes about 20% of students typically join a sorority or fraternity. You've got current data, and now you want to know, is the proportion in your sample significantly different from that 20%? That's exactly what a one proportion z-test is designed to answer. Let's break it down. Our research question is the proportion of students in our sample who joined a sorority or fraternity different from 0.20? In other words, are more students joining than expected, or fewer? Here's how we walked through the decision tree. First, we are testing hypothesis against a hypothesized value. We're analyzing a categorical variable, whether or not a student joined Greek life. We're comparing the observed proportion in our sample to a known or hypothesized population proportion, in this case, 0.20. And our sample size is large enough that the normal approximation applies, meaning we expect at least 5 students in both the yes and no groups. That makes the one proportion z-test the correct statistical tool. And if you're thinking about using this test in a formal research project, here's a full walkthrough of the study design you'd want to document. Start with your research question and hypotheses, both null and alternative. Define your variables clearly, describe your data preparation steps, explain the method you're using and how you calculated or entered group proportions. Mention any assumptions you checked. And finally, report and interpret your test results, ideally with the comparison, test statistic, p-value, and what it means in context. This structure turns a simple test into a publishable mini-study. The one proportion z-test tells us whether the proportion of students in our sample differs from the 20% benchmark in a statistically meaningful way. It gives us the observed sample proportion, a z-score that measures how far off our result is from the expected, a p-value to assess whether the difference could be due to chance, and often a confidence interval to show a plausible range for the true proportion. If the p-value is small, typically less than 0.05, we reject the null hypothesis and say, yes, the proportion of Greek life students in this sample is significantly different from 20%. Let's run this test in SPSS. Here's how. Go to Analyze, Non-Parametric Tests, Legacy Dialogues, Binomial. Select your binary variable, whether the student joined a sorority or fraternity, then enter your test proportion, 0.20 in this case. Click OK. SPSS returns the observed proportion of students who joined, as well as a binomial test result, which includes a p-value based on comparing that observed result to 20%. If that p-value is less than 0.05, we conclude that the proportion in our sample is significantly different from 0.20. First, we see the statistical significance checks out, but we also see the value it is testing is against the observed proportion of non-Greek against 20%. So we need to run it again against 1n, so 80%, just to correct for the right test proportion. And in doing so, we find the p-value is not below 0.05, so we cannot conclude that the proportion of Greeks on this campus is different than the hypothesized value of 20%. And that's how we use the one proportion z-test to test a single percentage against a benchmark. In the next video, we'll step it up. We'll compare two proportions, like the percent of on-campus versus off-campus students who joined Greek life. That's where the two proportion z-test comes in. Hit subscribe to follow the full series and stay curious.